Well, welcome to our lesson on solving systems of equations algebraically. Today we're going to be learning two different methods of solving systems of equations. And the two methods we are going to be learning are substitution and elimination. And then we're going to be using a little bit of that vocabulary that we learned in our last video with the consistent and inconsistent systems and dependent and independent. So first of all, to solve a system using substitution, the process we're going to use is to be able to just go ahead and pick one of the equations and solve it for a variable. Most often this first step you're going to do based on an equation that has a variable with a coefficient of 1. Those are the easiest ones to solve for. And then we're going to substitute what we get on the right-hand side into the other or the opposite equation. And then we're going to go ahead and solve for the variable and plug that variable back into any one of our equations to find the second variable. So this makes a lot more sense rather than just saying it in words to actually do some examples. So let's go ahead and take a look at some examples. So this example, we have two equations here and two unknowns. X and y are our variables or our unknowns. And so we need to solve for both x and y. So when you look at these two equations, I have a coefficient of 1 for x, there's a 1 there, right? Or I have a coefficient of -1 for y. The easiest one to solve for is the one that has a positive 1, so I'm going to solve the first equation for x, and it will be in terms of y. So I have x plus 2y equals 8. So if I subtract 2y from both sides, I get x equals 8 minus 2y. So that's our first step is completed. Our next step is to go ahead and substitute that right-hand side, the 8 minus 2y, in for x. That's what x is equal to. Now the key to this one, make sure you're not substituting it into the same equation. You have to substitute it into the second equation because we solved the first equation. So this goes into the second equation, which I've written right here. And anywhere you see the variable x, we're going to replace that with 8 minus 2y. Now this is a quantity, so it needs to be in parentheses when we substitute it. So there I've substituted it. Now we're going to go ahead and distribute the 1/2 through the parentheses. So half of 8 is 4 and half of 2y is 1y. So we have 4 minus y. That's from distributing the 1/2. And then we have another minus y equal to 18. Combining our like terms, we get 4 minus 2y equals 18. And subtracting 4 from both sides. So we have our minus 2y here, and then I subtracted 4 from both sides to get minus 2y is 14. And then dividing by -2, we end up with y equals -7. So we have solved for our first variable. We're halfway there. Now you can take this -7, that's what y is equal to, and substitute it into any of the equations that we started with. So I have chosen the first equation, x plus 2y equals 8, and I'm going to replace that letter y right here with the value -7. So 2 times -7 is -14, so we get x minus 14 equals 8. Adding 14 to both sides gives us x equals 22. That tells us that the solution to our system is 22, -7. Remember, it's an ordered pair. In our last lesson, we learned how to solve these graphically, so just keep in mind when you're solving for x and y, that's telling you the intersection point of the two lines. Here's one for you to try on your own. I'm going to keep moving on. Go ahead and solve this one and write what x and y are equal to in your notes. And we're going to learn how to use elimination this time. So when you're using elimination, you want to eliminate one of the variables by we're going to use addition all of the time. You can also use subtraction, but I find that students tend to make mistakes with subtraction, whereas if we just use addition, there's a lot fewer mistakes made. So one of the things that we're going to do is we're going to multiply one or both of our equations by a number or a constant to make sure that we get coefficients that are the same number but opposite signs. Let's do some examples so this makes more sense. We want to use elimination on this system of equations. So I have equation 1 and equation 2. You'll notice that equation 2, the b variable, they both have a coefficient of 2. And now if we just have an opposite sign, we could add them and the b terms would drop out. So what I did is I went ahead and multiplied the second equation by -1. And so as long as you multiply every single term by -1, this that I have down here in red is just equation 2 multiplied by -1. Now if we add these two equations together, okay, I get 2a, 4a minus 2a is 2a. My b terms drop out, they add to 0, and 15 minus 7 is 8. And solving for a, we get a is equal to 4. So now, just like before, we can substitute that value into either equation from the beginning and go ahead and solve for our opposite variable b. So I went ahead and used our second equation, equation 2, where it says 2 times a. Now instead of a, I'm going to replace that with the value 4 since a is equal to 4. And then I get 8 plus 2b equals 7. And subtracting 8 from both sides, I get 2b is equal to -1. So b is -1/2. So this time the solution to our system is 4, -1/2. Here's one for you to try using elimination. Bring your solutions to that to class. And we're going to do a couple more examples here. Use elimination to solve the system of equations. Now this time, none of my coefficients have the same number. So I need to figure out a way to make my numbers the same, my coefficients the same, but opposite signs. Well, in this one, I have opposite signs for my y variable, so I think if I just take equation 1 and multiply it by 2, and take equation 2 and multiply it by 7, then I'll have the same coefficient with opposite signs. And now when I add my two equations together, that y term will drop out, so I'll only have one variable. So adding those together, here's what I get, and dividing by 41, I get x equals 7. So now we want to substitute x equals 7 into any of my above equations. Usually the smaller numbers are easier to work with. So I'm substituting it into equation 1. So instead of x in equation 1 right here, I'm going to put that positive 7. And then multiplying that out, I get 21 minus 7y is equal to -14. Subtracting 21 from both sides to isolate my y variable, and then dividing by -7, y turns out to be 5. So the solution to this system is 7, 5. That's the point of intersection. So if you add or subtract two equations in the system and the resultant is an equation that is false, usually this is when your variables drop out and you get two numbers being equal to each other and it's false, we say that the system is inconsistent. There are no solutions. Now if that happens and your variables drop out and you get a true statement like 3 equals 3, then we say the system is dependent. So it's consistent and dependent. And we talked about that a little bit in our last lesson as well. So let's take a look at an example where this happens. It says use elimination to solve the system of equations. So in this system of equations, I'm going to multiply this second equation by 2 so that I'll have the same coefficient for my y terms. They already have opposite signs. When I multiply the second equation by 2, this is what I get. And when I add my terms together, when I add the equations together, both of my variables drop out on the left-hand side. And I get 0 is equal to 35. Well, that's a false statement. Since that's a false statement, there are no solutions, and the system is inconsistent. So that's kind of an example of what would happen when your variables drop out. Now, if I had 0 equals 0, that would be consistent and dependent. And that will do it for this video. We'll see you in class.